Hey guys, I'm just going to film this short video on our financial reporting class. The teacher did talk a little bit about these PV calculations that I'm going to go through, and she suggested drawing a timeline, but didn't actually draw a timeline. And I find the answer solutions she provided to be a little bit confusing, so I'm sort of hoping to sort them out all here in a way that makes a little bit more sense. So, to talk about PV, or present value, one of the things we're going to have to talk about is the time value of money. And the time value of money sort of means two things, very simplified. First, that it's more beneficial to receive $1 today than it is to receive $1 at pretty much any time in the future, because money is going to grow in value over time because of interest. And the other thing is that we need to compare money on the same date. So if we want to compare different sums of money, such as money we receive in the future or money at a different point in time, we need to use the present and future value equations to move the money to the same date. And in this case, for this particular question, what we are looking for is PV. So we need to move every sum of money to today or right now. That's what we're looking for. So essentially what we're being asked here is, how much money do we need right now in this particular moment to be able to make these 5 payments of $130,000? So I'm just going to get into these sort of two calculations. The first is that in the question, we're told the annual payments are $145,000, but that $15,000 of that is insurance. Now, this wouldn't be part of our lease payments. This would be part of our insurance expense. So we're not actually going to count that as part of our PV. We're going to subtract that out, and we're going to get $130,000. And we're going to see that the sort of ending value of these payments, the amount we're going to pay out in total, is in theory $650,000. But when we look at our actual PV calculations, we're going to need significantly less than that amount because of the time value of money. We'll be able to invest that money and grow it, and it will increase in value as those 5 years pass. So, very simply, we're just going to fill out this little chart. In particular, we're going to look at how many payments per year, how many times we compound the interest, the total number of payments, the interest rate per year, the actual amount of the payments, and the future value. And PV, what we're actually looking for here, isn't known yet. So the first thing we're going to do is we're going to fill out this chart, and these are all going to correspond to buttons on the calculator if you prefer to do this on the calculator and not in Excel. So we can see we make one payment a year, right here. Annual lease payments are $145,000 per year for the first 5 years. And we can also see, we'll need this later for our formula, that the payments are due at the beginning of each year. So this is a little bit rare. Normally payments are due at the end of the period, but Excel and your calculator can handle this. So we're going to make one payment a year, and we're going to assume, since it doesn't mention compounding periods, that there's also one per year. Now, we're moving this back in time 5 years. So since there's one payment a year, and we're moving back 5 years, that means we have 5 total payments. We can see there's 8% interest per year, and each payment is going to be $130,000. Now remember that this is payment that we're paying out. It's money that's leaving our bank account. So it's going to be a negative number. And finally, the future value of this money is 0. We will have paid off all the debt we owed, the money owing on the lease. So we won't actually have a future value. So next what we're going to do is we're going to press equals PV, and we're simply going to fill out our formula. In this case, our rate, then the total number of payments, in this case 5, the amount of the payment, or PMT, that's the same as the button on our calculator, the future value, and the type. And in this case, we will use the 1 flag since we're paying at the beginning of the period. And we'll just adjust this so we can see it. and we'll see that we get $576. So we can see that this is less than if we were to just add up the amount of all of the $130,000 payments. This money will grow in value. So we need almost $100,000 less than the total value of the payments. So next we're going to see that the payment value is going to change over the next 3 years. It's going to go down to $100,000, and again we're going to subtract out our insurance fees from that, leaving us with a total of $85,000 per payment. And this is actually going to have 2 steps. And let me just show you this part of the question. First, we need to see the value of those $85,000 payments at the 5-year mark. We're going to move them back to this point. Then we're going to move that lump sum. That will become our future value in this equation. We'll know the future value and we'll need to go all the way back to today, during the time that we didn't make any payments. So let me just show you how to do this. First, we'll handle this part, which is pretty much identical to the part above. 1 payment per year, and again, since the compounding periods aren't mentioned in this question or addressed, we're going to assume that they equal the payments per year, 1. N, this time it's going to be 3 because we're moving back in time 8 years to 5 years, and that's only 3 years worth of payments. The interest per year is the same. The PV we don't know. The payment is $85,000. And again, remember, this money is coming out of our bank account. So we want to make sure that's a negative number. It won't actually change our final value. It'll just cause PV to be represented by a negative number, and we just want it to be nice and clean. Finally, our future value is 0. We will have paid off this entire lease. And we can do this in the exact same way. PV, our rate of 8%, our number of payments, 3, the amount of our payments, $85,000, the future value, 0, and again, this is the beginning of the period. And we're going to see that this is roughly equal to $236,578. But we're not quite at today yet. We've moved back from 8 years to 5 years. So at this 5-year mark, we would need this $230,000 to pay off each of these $85,000 payments. But we need to go all the way back to today. So we need to know, in order to get that money, that $230,000, how much money do we need right now in this very moment? And to do that, we need to move that money back. So here we are in step 2. And we're going to move the money back from 5 years in the future to today, so we can see what that amount is worth today. So in this case, our future value will equal our old present value. We're going to have a $0 payments because during this time, we're not actually using that money to make payments. We've already handled the payments we're making during that time up here. So this $230-ish thousand isn't being used to make payments. So the payments per year, though, would still be 1. The compounding value, 1. The rate hasn't changed. Sorry, that's the number of payments. The rate hasn't changed. It's still 8%. And this time, the number of payments is going to be 5 because that's how far back we're moving it, these 5 years back to today. So we can just use the PV function again. Oops, sorry about that. We can just use the PV function again, entering the numbers from this chart. Our rate of 8%, our number of payments, 5, the amount of our payments, in this case, 0, and our future value, $230,000. Then again, we remember this is the beginning of the period lease, and we're going to use 1, the 1 flag, for all of our PV calculations. And you can see that this has come up negative. That's why it's colored in red, because I forgot to make this number negative. So this is the right answer, and this is exactly what I talked about before. This is just because I didn't make this number negative. If you look, and if you see if I make the future value negative, it'll make this a positive number. And this is going to be the amount of those payments that we need on the very first day we take this lease, right now, today. And finally, we have our last payment stream. We need to make a single $40,000 payment at the very end of the lease in 8 years. So in order to pay that $40,000, how much money do we need right now? And this one is also going to be simple. It's going to be fairly similar to payment stream 1. We're just going to move this $40,000 back to today. So in this case, our payments per year are still 1. Our compounds per year are still 1. Our number of payments is 8 because this time we're going back 8 years. Our interest rate of 8 hasn't changed. We still don't know our present value. That's what we're looking for. Our payment is 0 since we're not making payments on this money. This $40,000 is our future value. So, and again, sorry, remember this needs to be negative. I'm just screwing up this formula here. So this needs to be negative because remember, this is money we're going to pay out to the people we're leasing this equipment from. So we can just use our PV function again, filling out all of our variables, our rate of 8%, our number of payments, 8, the amount of our payments, we're not making any payments, so this is 0, and the future value of 40,000. And again, remember, we'll add our beginning of the period flag, close our bracket, and we'll get $21,611. And now we have all of the money moved back to today. And we can see the total amount of money we're going to need to pay off everything we need by adding up all of our present values. So this is essentially going to be where we add the present value of our first payment stream, of our second payment stream, which is here, because remember we had to move this twice, so we're not really worried about this first one, and our final payment stream, which is down here. And if we hit enter, we're going to see that we're going to get $7,400,000, $3,198, and that's going to be the final answer here. That's going to be how we calculate our PV.